Hey, so in the last video of the adjacency list model in Postgres, that's the graph, or that's the tree we have now. That's the roots, and these two are the immediate children for this node, and these three are the immediate children of this node. It's pretty simple tree, and the way, because in this table we will store multiple trees, the way we distinguish between them is having this tree ID, which should be a unique ID per tree. So this thing, you should remember to add it in each one of your queries. Okay, so now let's look at some ways to query this. And the first and simplest one is to find the root node. So the root nodes, as we discussed in the first video, they have null ID as parent ID. So you can get them like this, which is pretty simple. But maybe this is not the thing you are looking for, because if you have so many trees, you need to add maybe different kind of condition. But the main idea here is the parent ID is null, but you can also add where title is equal to something, or where tree ID is equal to something. But this is the main point here, and that's pretty simple. Now to get the immediate children or the immediate nodes for this node, I know the parent ID of it, so I can say where parent ID equal to 1. Now these are the immediate nodes for this node. Later, or maybe in next video, I will show you how we can query the whole, query a specific path or query the whole tree, not to get only the immediate children, but to get the full tree of nodes. We will use recursive queries. Now, since we're talking about immediate nodes, I'll show you how we can find the count of each immediate node find the count of nodes that are immediate to each node that has children. A bit mouthful, but I'll show you how. So I'm gonna say select the star for now. From categories, I'll call it parents. I'll inner join it with categories itself again. I'll just keep it as C on C.parent ID equal parents.id. Now, if I do this, you can see these are the parents we have. I'm basically getting the parents and joining them with each immediate child they have. So fruits has apple and mango, and apple has these three. So you can see it here. I think it's pretty straightforward. This is usually what I do before actually adding any kind of conditions or groups in my joins. I just look at the result, try to understand it. But from this one, I can just say, hey, give me the parent to title, and now count, which is the immediate children. Maybe I should call it immediate children. Count IDs, group by parents.title, which is true. Apple has 3 children, immediate children, and fruits has also only 2. So that's how you get the count. Another thing is how we can find leaf nodes. So there are 2 ways. I will start by the most obvious one, which is a subquery. So select the star from categories C, where C.id not n. Because if you think about it, before writing the query, if you think about it, leaf nodes, their IDs won't be in the parent ID because they are not a parent to any other node. So their ID won't appear in this column. So the only thing you have to do, give me all of the rows where their ID does not exist in the parent ID of the same table. So it's like the first thing that comes to my mind is a subquery. But there is a catch here. I will show you. It's about comparing nulls. I hope I can explain it in a good way. So I'll select from categories C2. So C2.parent ID. This won't give us anything, but if I selected this this query, it will give us these like 1, 1, 2, like 1, 2, and a null. So if I say where c2.parent ID is not null, this will give me only 1 and 2 as a list. Now if I run the whole thing, I will get the leaf nodes. So what happened here is when you compare null, which is considered an unknown value, this will give you back null. So when you say give me all of the values where a specific column not in the result of a subquery, this is translated into the following thing. Or it's the same as saying, hey, select this thing where 3 does not equal to 1. So maybe I will just explain it in a different way. Wait. This thing here looks like this. So select these rows, or in our example, this value, where this value is not in this list, and this list contains null. So what the SQL engine behind the scenes will do, will compare null with each one of these values with an AND condition. If I run this, we won't get any value returned. It's an empty result. And this is translated into the following query. It's the same as saying this. Select this value. I mean, I could say 3, where 3 does not equal to 1, does not equal to 2, does not equal also to null. Does not equal to 3, and does not equal to null. So I can't run it. This will also not give me any result. Because when you compare, I'll show you. Select 1 equal to null, or 1 equal to 1. This will give you a true. dbeaver will just add it as a check mark, but this is a true. If it's equal to 2, this will give you a false. I hope you can see this. Okay, this will give you a false. What if say select 1 equal to null, this will give me nothing, or null, which is converted, I think, to a false. Maybe it's a falsy value, but this is what happens here. So when you go say select this value where it's not in this list, this will be an AND condition, and because comparing a value to a null will yield to a null, so the whole thing will not work because it's not there. But if you say select where value is in, where 1 is in any of these, in this list, which means it's an OR condition. If you run it, you will get a value, and this is an equivalent to this. So select this value where it's in where it exists in this list, which is an OR condition. So it works. I hope I explained it in a good way. I'm not sure. But basically, when you compare null to a value, the result is null. And when you say it's not in this result, the search condition is an AND, and it won't work because it needs to not exist in all of these values. But when it compares this value, which could be a number, to a null, it will result to a null. Null is false, so it won't give you any result back. So that's one way to get leaf nodes, a subquery, which is the most obvious way, in my opinion. Now, another way is by joins. We already wrote a query to get us the count for each immediate node, like this. But we can play along with it or twist it a bit to find the leaf nodes by just doing a lift join. So let's remove this group by and let's select everything. So if you look at the result, I will try to look at the result, maybe twist the query, then find the leaf nodes. All of the leaf nodes are actually here. It's, I believe, mango, green apple, yellow apple, and red apple. So I'll call this leaves now. Leaves. I'm pretty sure that's a typo. Leaves? Leaves. I'm sorry. I'll just say this. Yeah. Okay. So I will go do a left join and just see the result. I mean, right join I think won't give us anything. Okay, it will give us the root. Doing a left join will say give us all of the also give us all of the rows from this table where this condition does not apply, which means where their ID does not exist as a parent ID in the same table. Right join does not. Right join is the opposite. Basically, give me the root, which says give me all of the rows from this table where its parent ID does not exist in the same table itself, which is null. Null does not exist there. So it will give you the root. But left join will say give me all of the rows from this table where their ID does not exist as a parent ID. So what you can, to finish this query, you can say where leaves, no, where C2, which is this part, .id is null. So this will give you the leaf nodes, and you can say leaves.id, leaves.title. These are the leaf nodes. So I think this is part one of how to query this. I will continue later. Bye.